we know that 19,000 is going to have to equal 18t squared plus 136t plus 6444. And what I'm doing from here is solving for t. So you set one side equal to 0. You set one side equal to 0, you get 0 equals 18t squared plus 136t minus 12,556. I don't know about you, but I am not going to factor that, nor am I going to try to complete the square or any of that. What I'm going to do is use the quadratic formula. The quadratic formula is going to give me zeros, one positive and one negative. I'm talking about time. Do I want a positive or a negative? I want a positive value. So quadratic formula, opposite of b plus or minus the square root, b squared minus 4ac all over 2a. Fill in the blanks. Opposite of b, negative 136 plus or minus the square root, 136 squared minus 4 times 18 times negative 12,556 all over 2 times 18, which is 36. Yes, that looks daunting. Yes, that looks kind of nasty, but all you have to do is figure out what's in the discriminant. Your discriminant, remember, allows you to figure out the number and type of solutions that you're going to have. If it's positive, 2 real. If it's negative, 2 imaginary. And if it's 0, 1 real. Here, when you type that through, we get 922,528. That's the discriminant. Take the square root of it, I get 960 and change. So I wind up with negative 136 plus or minus 960.48 blah, 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 all over 36. To get my solution to be a positive value, am I going to add the 960 or am I going to subtract the 960? Add that. I'm going to add them together. That way it'll allow me to get a positive numerator. I want a positive numerator because my denominator is positive. In some of the other problems, you had a negative denominator, which means you wanted a negative numerator to get your positive values. That's the kind of thing you have to be able to decipher. Okay? So when you do that, we wind up with, add to that, what was it, 136? Or excuse me, subtract to that 136. And then I divide it by 36. And I get 22.9 years. When I add 22.9 years to 1979, I get 2001.9, which is basically 2002. Okay? It's when you're using your calculator to use quadratic formula, the mistake you're going to make is that you're going to write down if your b value is negative 4, you're going to type in negative 4 and square it, you're going to get negative 16. Make sure you group them. Okay? What other one do you want to look at on that back page? The equation is right in front of you.
I know, but
Height.
I don't know like H and S is 12 or 6.
When it hits the ground, what's the height?
0. Wait, that was rude of you. That one doesn't count. I think I could do it.
I hope so.
Plus 12 is that.
Subtract 12 and divide by negative 16. You get a positive value, take the square root. And it wants it in terms of seconds. 0.87. Yes, sir?
For the last problem,
Yeah.
what did you add?
To 22? Oh, in the problem it said t equals 0 corresponds to the number of new cars purchased in 1979. That's where this model came from. It's starting in 1979. Any others in the word one? Same idea when you're using a rocket. You're on top of a hill. You're shooting the rocket. Boom! You jump.
So it's gonna be negative.
Think about it. Here's your 0 line, right? You're starting here at a height of what, 80? You have 80 feet to start with. So this could still come out back here. Whoop! It went away. There's Rocket. So you're still looking for time. In this case, you're looking for time. Can time be negative?
Oh, no, I'm sorry.
It's kind of funny. This one has the negative 88. So we have 88 miles per hour. You didn't have to. It just helps to visualize what's going on a little bit easier. So you're given the model, negative 16t squared plus 88t plus 80. And you want to figure out how long would it be until it hits the ground. So that means your height has to equal 0. You set that equal to 0. And once again, are you going to factor that? Are you going to complete the square? Or are you going to use quadratic formula?
Complete the square.
Complete the square. You're crazy. Quadratic formula. Use quadratic formula. Opposite of b plus or minus the square root. 88 squared minus 4 times negative 16 times 80. All over 2 times negative 16 is negative 32. Now, in this example, do you see how my denominator is negative, and I want to deal with a positive amount of time? So am I going to subtract my discriminant, or am I going to add my discriminant? I'm going to subtract it because it's negative. The dead giveaway on these types of problems is because I'm talking about time. I want a positive value for time. My denominator is negative, which means to get a positive value, my numerator has to be negative. That's why I'm going to take negative 88, subtract whatever my value underneath the radical winds up equaling, divide it by the negative 32, and you should get 6.3 seconds. Because I think it said rounded to the nearest 10. Okay? And that's what it works out. All right? Let's go start with page 1. Oh, sorry.
What would you do in the case of, like, say if you were to add it, it was still negative, so like then you could have 2
I see what you're saying, but most of the models that we're dealing with that won't happen. But that's a great question. I wouldn't worry about it. Okay. First page. 4. Most people have had issues with 4. So let's look at 4. Number 4, we have 2x squared minus 15x plus 35 is negative 7x. I have to do this by completing the square. And if you factor it into the instructions say complete the square, what happens?
You lose points because you were irresponsible.
Oh.
Yeah.
Make sure you set that up, okay? Subtract or add 7 over. We have 2x squared minus 8x. And I'm going to go ahead and just do this right away. I know I'm going to have to move my value of c. But the other thing is that in order to be able to complete the square, the one rule that we have to have, a has to equal a positive 1. In order to get a equal to a positive 1, what do I have to divide everything by? 2. Divide everything by 2, you wind up with x squared minus 4x blank equals negative 35 over 2. And just leave it as that for right now. Now complete the square. Take half of b. What's half of negative 4?
2.
Negative 2. That's my term, x minus 2. Square it, and I add 4 to both sides. In this case, I added 8 over 2, which is the same thing as 4. Do you agree? What's negative 35 and 8? I get negative 27 over 2. Now I have to take the square root before I do everything else. When I take the square root of both sides, when you take the square root of a fraction, make sure you write it like that, to remind yourself that you'll have to rationalize.
That's
20. Well, we're not done yet. 27 Is there a perfect square that you can factor with 27?
9, 3.
9, 3. So the square root of 27 would be 3 root 3. So the square root of negative 27 would be 3i root 3. Good. So now I'm down to x minus 2 equals plus or minus 3i root 3 over the square root of 2. Now I'm going to get rid of the radical in the denominator. To get rid of the radical within the denominator, I multiply the top and the bottom by, well, that radical. Square root of 2 times the square root of 2 is 2. So I have x minus 2 equals plus or minus 3i. Root 3 times root 2 is root 6 over 2. And then lastly, move the 2 over. So I get 2 plus or minus 3i root 6 over 2. Now that's not the answer the back of the book gave you. The back of the book gave it as 4 plus or minus 3i root 6 all over 2. You can leave it at that. All they did there is they got a common denominator and wrote it out as one giant fraction. These are the same. Okay. Yes, sir.
Don't you have to multiply both sides by 2 squared?
The square root of 2?
Yeah.
No, because I'm just worried about rationalizing just this denominator. I'm not multiplying to keep things equal. I'm just changing the form here.
Oh,
I'm
okay.
multiplying it by a factor of 1.
Okay.
That's all I'm doing. Okay, I'm just multiplying by a factor of 1. All right? You guys don't have to get a common denominator to do that. That's why they gave you that answer. Okay. What else on that front page? Yes, sir.
Factoring the number 5.
Number 5? Factory number 5?
It's just. I divided everything.
Bring it over.
And
Why?
because it makes everything small, then you get a decimal. So,
Two ways you can go about doing this. You can go ahead and find a GCF to start with, because they're all even.
well,
12 doesn't go into 16.
4.
If you go by 4s, it makes your life a little bit easier.
It was almost really good though.
He was this close. What was that 36? Here's where people have had questions so far today. Do I need to keep the 4 here?
Yes.
No, I don't. The reason why I don't need to keep the 4 here is because of that crazy little sideways symbol that looks like an 11 that fell over. The equal sign. Okay? That equal sign tells me now, since I'm trying to solve for zeros, trying to find my solution sets here, since I factored the 4 on the left-hand side, if I divide both sides by 4, it goes away.
Yeah.
Okay? So, what's that? Yes, I'm exterminating. Now, if I did this correctly, could I factor out more?
Yeah.
2.
Yeah.
2.
That's smart. Hey, Jack, if you
So now-
do that one more time, I'll tell him.
That just meant that I could have factored everything out by an 8. It doesn't matter. So now you're at the point again when you have leading term coefficient that's not equal to 1. Do you guys remember how to find your terms via the calculator?
Y
Y equals? What am I said? Y?
Negative 15 divided by x divided by negative 3.
Something divided by x. Okay, what's the something?
15 negative
X divided by 15.
36. Remember, 36 is always first times the last.
Oh, yeah.
So what you're doing in the calculator to help solve, if you can't remember your terms, you're taking 2 times 18, which is 36. Divide that by x, and you're looking for your integer values. Okay, you're looking for your integer values. And that's how you factor through. It's the quickest way. And then you have to do your grouping part. All right. What is it? 9 and 4?
No.
I don't know.
6 and 3 halves.
6.
Oh, no, that's the answer. Sorry. I didn't do it factor.
Quadratic.
It's -3 and -12.
I used the quad form, but
Well, if it said by factoring,
I know. I couldn't do it. I didn't know how.
I'll make sure you remember.
I'm gonna have to learn. I know. Even if it's at
Go by GCFs.
Well, there's no flex, that really stinks.
Now when you have your zeros at this point, you have 3 halves and 6. Your zeros.
That class one comes out the same way. I don't know why.
And the quadratic formula will help you check your work.
That's so much time. I can do that.
What else on the front page? Yeah.
I got like 4x minus 6 times 4x minus 24 for 5.
But here's what happens. Your answers when you get your zeros, the same zeros, but you worked with a non-simplified version of the top part. That's all.
Oh, so can I like
You'll still get the same answer.
divide that like by 2?
Yeah, that'll still work. Because now when you set those two terms equal to each other, you're still going to get 3 over 2 and 6. The only thing I did by doing this, by factoring out that GCF, it was just quicker. It's a little bit easier. But if you're using your calculator, you're fine by dividing by the square by the x value to work it that way. It doesn't matter. You're going to get the same result. Okay. Anything else on the front page? All right, second page.
I think I'm pretty bad at solving equations by taking.
Oh yeah, what does that even mean?
11. Solving equations by taking the square root of both sides. You all right? Can I go? Number 11, I have 8x squared minus 8 is negative 209.
Alright, so we take the square root of everything.
No, can't do that yet. In order to take a square root, I have to have just x squared on one side.
Also divide everything by 8.
No!
So add 8.
Add 8, so I have 8x squared is negative 201. Now, what do you have to divide by? 8. Divide by 8.
So you divide by 8, right?
Now you take the square root. So when you take the square root of both sides here, you get x is going to equal plus or minus the square root of negative 201 divided by the square root of 8. Remember, anytime I have a fraction, I'm taking the square root of it. I'm rewriting it as the square root of the numerator and the square root of the denominator, because one or both of them might be able to be simplified before I go any further. When you guys see the square root of 8, you should know that. Wrong. Very good. I know the square root of 8 is 2 root 2.
Yeah, because 2 times 2 times 2.
I also, when I have a negative 201, what do I take out of the 201?
200.
I. So I have plus or minus I root 201. Now, I don't know if has anybody gone into the calculator, is there any factors of 201 that work?
No. 7 actually.
49?
I think it might have worked.
I don't remember if this was the one that had that. Which number is this? 11?
201 divided by
It's probably just a mess.
29 negative 7.
Yeah, it doesn't work. There's another one that has 29 in it. So, 201 does not simplify radically. So that means I have to just get rid of the radical in the denominator. Once again, I multiply both top and bottom by the square root of 2.
That's and then 2 root, wait, so 2 roots. So you should get 4.
Correct.
Yeah.
The denominator now becomes 2 times the square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is 2. 2 times 2 is 4. So I have 4 in the denominator. My numerator is still plus or minus I root 402. And that's my solution. Okay? And that's the solution.
But, okay. What number was that?
Third.
For some reason, they have like. Oh, I don't know what I did. I have 4I root 4 of. Oh, wait. It's the same thing. Because then you just divide by 4.
That's okay.
Right? Because wouldn't that work? Like, x equals plus or minus 4I root 4 of 2. Because then you just divide out the 4 and then that's all it will. Right?
No. I don't know why you were off the 1. 4 should be in the denominator.
I don't know how I got that.
Yeah, it should be
It
out.
works out, right?
No, it doesn't just float that.
But no, but then it
Because in order for that to work, your denominator would have been 16.
But can't you just divide everything by 4?
There's no on both sides. Where's the other side?
Okay, I'll show you what I have.
Did you have a 4 on the other side still somehow?
No, actually, x equals. Oh, no, because then it'd be 1 4. kill me, dude.
No, you just made put in the silly mistake, Charlie.
I don't, yeah, I just paid $5.
Second page. What else? Sure. Quadratic formula. 3x squared minus 18 is 10x. In order to use quadratic formula, you got to get everything on one side. Move the 10x. We have 3x squared minus 10x minus 18 is 0. Which means my A is 3, B is negative 10, and C is negative 18. At that point in time, most people will forget to put parentheses around the B value when they square it. Remember, x is the opposite of b plus or minus the square root b squared minus 4ac all over 2a. 10 plus or minus square root 100 minus 4 times 3 times negative 18
Plus.
all over 6. Okay? 4 times 3 times 18. I don't know what that was.
4 times 3 times 18, 316.
316.
No, 216.
216. Add the 100 to it. I get 10 plus or minus the square root 316 all over 6. Which means now I have to start looking for perfect squares that work with 316. Go to your calculator. Y equals 316 divided by x squared. Go to your table.
2 root 79.
I'm looking for perfect squares. When you have that, I get 2 root 79.
No, he said no.
2 root 79, no, what is this?
2 root 79. That's what you do. You look at your perfect squares, because that's 4.
Now, all of these guys, 10, 2, and 6, they're all divisible by what? 2. And that's how you simplify these. You get 5 plus or minus square root of 79 all over 3. Okay? Yes, sir.
Wait, how is it there? 2 square root 79.
When you look in your calculator, you're looking for the smallest value of y that's not a decimal.
Yeah.
That's the radical. That's the number in front.
I thought it had to be a square.
Well, yeah, because 316 breaks out to be the square root of 4 and the square root of 79. So you get 2 root 79.
Oh, I don't know.
1 root 79? I thought it was 2 79.
Well, because the square root of 4 is 2. What's the largest perfect square that goes into 316? Square root of 4 goes in there. Remember, the shortcut was to divide out by the square root.
Oh, you already in the y equals, you
Yeah.
already, oh, okay.
Yeah, I already, yeah, I already pressed the buttons.
Gotcha. I thought you were looking at the factory. So
No. No. Yes, ma'am.
I did 20.
Which one?
20.
20. 20 is written backwards from what you're normally used to seeing, but the first rule of factoring never changes. What's the first rule of factoring?
Divide by
5 by 7.
Oh, really?
Find the GCF. In this case, all 3 of these terms are divisible by 7. You get 81 minus 18 plus b squared. Now, even though this is written backwards from what you're accustomed to seeing, can't I still ask the question, what times what's 81
9.
that adds together, excuse me, what times what that's 81 that gets add together get negative 18?
Negative.
So you wind up with 7, 9 minus p, 9 minus p. Why did I have to keep the 7 as I rewrote?
Otherwise, it's not right.
What's that? What does this problem not have?
0 equal sideways 11.
Exactly. It doesn't have an equal sign. Whenever it doesn't have the equal sign, if you factor out a GCF, you have to continue to rewrite it because what you're doing is you're factoring it. Okay? Yes, ma'am.
Why is it, since it's like backwards, why are you doing 9 minus p when we're working with negative 9?
Because this is still, I have to wind up with a positive p squared, so it's, and have these two add up to equal the negative in the middle. So they have to be an alternating sign, or excuse me, they have to be the same sign, they're both negatives.
Shouldn't it be p minus
Well, yeah,
nine?
but
though?
what,
minus
but
nine.
the nines are positive.
Yeah.
Yeah, what's 9 times 9?
81. Yeah, but then you have to
What's
get
9 times
18.
negative p?
Negative.
Negative 9. What's negative p times 9? Negative 9.
It's the same, like, if it's just the same thing squared, then you can just flip the order always?
Yeah, because think about the order of operations. What's 3 plus 2?
2,
What's 2 plus 3?
5.
So isn't this the same thing as saying p squared minus 18p plus 81? It's the
Yes.
same thing. They just use commutative property to rewrite it to annoy you. It worked. What's that? P net, yeah, it's the same thing.
Yeah.
It works out the same. It's the same. Alright. Are there any others, gentlemen? Any others on that? Graphing. When it comes down to graphing, remember, all you have to be able to do, identify your vertex, some symmetric twins, maybe a 0 if you need, if you can, and then is it a solid or a dotted line, and where your shading is going. When we did those in class the other day, you guys kind of flew through those. I don't think there was much of a hassle. Your calculator will be able to find all those values for you. You just have to know whether or not you're looking at a maximum or a minimum when you're looking at your graph. The other part of the chapter that I didn't have really anything on here was when we dealt with some I. And I want to go back and revisit a couple of properties when you're dealing with I. For example, when you are working with something like this. When I'm dealing with something like that, I have to get rid of I in the denominator.
You 4 minus 5i.
Good.
Times. And then you just like FOIL it out.
That's all it is. Yeah. When we get to a problem like this where you have to worry about getting rid of the I in the denominator, you're once again going to be multiplying by what's called conjugate. You're using the exact same terms as the denominator, but you're changing the sign. You're trying to eliminate your middle term. So you're going to multiply the top and the bottom by 4 minus 5i. Because remember, 4 minus 5i divided by 4 minus 5i is still 1. We're just changing the shape. Okay? And like you guys said, it's a matter of foiling again. The denominator becomes a little bit easy since we know that the middle term is going to drop out. We wind up with 16 minus 25i squared. And what do I rewrite I squared as every time I see it? Good. So this becomes 16 minus 25 times negative 1, which is, what's my new denominator?
36. 41.
41.
Oh.
Is everybody okay with that? 16 plus 25. I get 41. Remember, that 5's getting eaten up real quick, isn't it?
Yeah.
Whenever you see an I squared, rewrite it right away in parentheses as times negative 1. It will help to alleviate some of your sillinesses. Now the numerator, I just go ahead and FOIL, like I would normally. My numerator, I get 8 minus 10i minus 12i plus 15i squared. Negative 3 times negative 5, I have the I squared. That positive 15i squared can be then rewritten as what? Negative 15, very good. So I have 8 minus 15, negative 10 and negative 12,
Negative 22.
and there's my answer.
Or you
Why are you allowed to subtract?
Remember, this 15i squared is 15 times negative 1. So I have 8
Oh, yeah.
minus 15. Okay? You get 8 minus 15. Now, in this case here, I had, my final answer was negative 7 minus 22i over 41. There's nothing between all three of those terms that I can simplify out. But if there was, like, let's say you had negative 2 minus 22i over 4. If you had something like that, what could you divide everything by? You could do something like that. Just remember to look at those three terms to see if there is something you can simplify out from. These guys, and I'll get next. Yes, sir.
How do you, what's the thing about adding I and subtracting? Like, is that multiplying?
That's simplifying the denominator. That's rationalizing. When you're adding and subtracting them, as long as you treat I like you would a variable. If it's 2i plus 3i, you get 5i. When you're adding, subtracting, treat it as a variable. When you're multiplying this way, remember the I squared rules. That's all you have to think about. Okay.
Foil.
Yes. Just
Why do you say why is it when it's I squared it's negative 1 but when it's alone it's
because it's alone. When it's just I by itself, that means it's the square root of negative 1. When it's I squared, it winds up being negative 1.
I thought that
That's the square root of jump squared, and you get the jump, and the jump in that case would be yeah. Okay. Once again, that numerator up there, I have 8 minus 10i minus 22, or excuse me, minus 12i, and then I have 15i squared, so it's plus 15 times negative 1. So here I have 8 minus 15, that gave me the negative 7. Negative 10 and negative 12 is the negative 22. And then the 41 just comes along. That's all. I just rewrite it above it sometimes to take up so much space. Okay. And that's where that came from. Imaginary stuff, yeah, remember, like he was asking, if you're adding or subtracting with imaginary, treat the I value like you would a variable. When you're multiplying and you're foiling stuff out, that's when you have to worry about I squareds become negative 1. The rest of the stuff, when we come back down to, is that section 5.8. 5.7 was the shading, the graphing and shading, which you guys really kind of flew through. I know I didn't have any examples of the overlapping ones, but remember all you're doing is just using two on the same graph paper looking to see where they overlap. Pay close attention to your plus or minuses, or your less than or equal to's. Okay, your lessons or less than or equal to. Make sure it's solid or high. The last couple of things I wanted to show you is just to remind you of what section 5.8 looked like. If you recall in 5.8, you guys kind of flew through it. There wasn't too much craziness in there. That's when you had to write stuff in terms like vertex form, standard form, or intercept form. So let's just kind of revisit that real quick just so we remember what we're doing. Whenever you're writing something in vertex form,
Is that A? Okay.
yeah, I don't want to do this one, that's a bad one. So if you want to write it into vertex form, that means you had to be given a vertex and a point, which means you have to remember what vertex form looked like. That was the y equals a x minus h quantity squared plus k. When I'm looking at this, when I have a vertex and a point, I'm given 4 out of the 5 variables here. I got to find a. That's what you're doing for all these three types. Whether it was vertex, intercept, or standard, you had to solve for a's, or in standard form, you solve for a, b, and c with the inverse matrix. So here I know that my vertex is my h and k, x and y. Please remember, if you're giving those values like that, label them. You're going to know how to do this. You're going to accidentally put them in the wrong order. Just label them. So I know that negative 61 is a 0 plus 6 squared minus 7. So I have 36a minus 7 is negative 61. Add 7. What do we get? 54. And then lastly, what do you have to do? Divide out. Divide by the 36, and then you should be able to simplify that out. What is that? 3, 9 over 6. Negative 3 over 2. So my final answer would be y equals negative 3 over 2 x plus 6 minus 7. Oh, quantity squared plus r minus 7. I just have to go back and go back. Vertex form, it's the same thing.
Wait, what is this?
Oh, I'm sorry, this is vertex. I'm thinking intercept form. Intercept form is basically the same thing, except you're given intercepts. Very good. Your intercept form was the y equals a x minus p x minus q, where your intercepts are the p and q value, and then your point would be your x and your y. Once again, solve for a. Yeah,
Are we going to memorize these?
you should know these, yes.
Oh.
So you have 77 is a, 14 minus 3, 14 minus 9, that's 11 times 5. So you get 55, 77 over 55 is 7/5. And then it's substitute back in. The standard form I thought was probably the easiest because you guys all freaked out and I scared you and all of a sudden you got to use a matrix. Remember that? Yeah. And it worked out pretty easy. When you're dealing with the standard form, that meant you're dealing with 3 points and you have the equation of ax squared bx plus c is equal to y. I guess you're finishing this one out. Oh, wait a second, we're going to finish that quick here. I'll re-explain. I'm going to put an example real quick up of standard form just to walk you through it real fast. Yeah?
Will you answer the calculator questions?
Usually what happens on a calculator when it comes to the test part, if you're coming up to me and your window is all messed up and your domain is bad, I will fix your window for you. Probably all of you.
Like if we forgot to like get to a matrix.
Alpha zoom. Yeah, I can say that. That's not a problem. If you forget how to get to a matrix, I'll say alpha zoom. Yeah.
Can we solve it without using matrices? Is that a problem? Because I hate matrices.
I don't care. Go for it. It's just you're making a lot more work on yourself. And then lastly, looking at the one with the matrix, remember if you're dealing with 3 points like this, you want to get it into the form of ax squared plus bx plus c is y. You're creating the matrix. You're taking the inverse, you're multiplying it by something, and it's going to spit out your A, your B, and your C. What in that first column? X squared. What in the second column? And what in the third? What was this column? Good. So you have 16, 9, 9, negative 4, negative 3, 3, 1, 1, 1, negative 7, 3, 21, and that'll spit out your answer. I don't know why you would do that by hand. All right, whatever.
Oh, the answers are all Y.
What's that? And then that'll give you your A, B, and C, and then you just have to resubstitute back in. People have been asking me throughout the day today also, what are some other problems to take a look at? Chapter review in this chapter is really good. It gives you,
Specifically.
it should be, I think so. It's a good thing to have to double check.